So in this video, we're just going to go over the absolute value of a quadratic and how to graph it and find all the points of interest. So we have this quadratic on the inside. We're just going to factor it because the factored form makes this quite straightforward. So I have minus x squared plus 2x plus 8. I'm going to factor out a negative 1, so I get x squared minus 2x minus 8. Now I can see two things that multiply to negative 8 and add to negative 2. That's going to be negative 4 and 2. So I get negative 1 x minus 4 x plus 2. Okay, so I can substitute this back in. Negative 1 bracket x minus 4 and x plus 2. Whoops, close that bracket. Now, I know this has a graph, and the graph is going to be like this. So my roots of the quadratic are at 4, right? Here x equals 4 and negative 2. And now halfway between your two roots is going to be your vertex. So if I added these two, 4 and negative 2, I get 2. And I take half of that, so that 1 is going to be my vertex. And the vertex happens at 1, so I put this in here. So 1 squared is negative 1, plus 2 is 1, so it's at 9. So this is the vertex, and it's at 1 comma 9. These are my x-intercepts, and I know the parabola opens downwards. Oh, this might not look so great. Oh god, that was okay. So this is what we've got so far. Now we want to know what happens. Usually, parabola just keeps going down like that. But we have the absolute value of this. So if I wrote f of x as a piecewise function, what I'd have is the positive version of it, which in this case starts with a negative, perfectly to confuse. And then I'd have the negative version of this, which is positive x squared minus 2x minus 8. So I changed all the signs of these. And I use this one if this is the natural graph, the one that we're graphing right now, if I'm in between negative 2 and 4. So if x is in between these 2 points, that's when I use this one. And this one, I'm going to use if x is bigger than 4 or x is less than 2. So then if it's over here, I'm going to use this one. And this one is going to have a mirror image of what's below it. And that happens to be this graph. This is this piece, and it has the image of that. And this one is this image. So now we'll state the domain. It's all x. So the domain of is x such that x is an element of a real number. And that just means we can have any x value here. Now, the range is y such that y is an element of a real number, but y also has to be positive, right? We can't have a negative output with an absolute value. So we have a positive, so y has to be bigger than or equal to 0. And that's how we get all the important parts here. We have our x-intercepts, and that is going to be at 4 comma 0 and negative 2 comma 0. The only point we don't have is our y-intercept, but that's quite easy to find. That's when x equals 0. So we just put a 0 in here and we find that it's 8. So our y-intercept is actually at 0, 8. And that would be the last point that we'd have to find on here. But this is exactly what the absolute value of, or this is what the graph of the absolute value of a parabola is.